This video is going over optimization, and I'll be covering the third example that we had on our review sheet. And it said, what dimensions will give the largest area of a rectangle that can be inscribed in a circle with a radius of 4? Okay, so it's asking how big of a rectangle can we put inside of the circle. Basically, that's what inscribed means. So, what we need to figure out is our equations. Okay, so on the left, you'll see the rectangle, and the area for a rectangle is equal to x times y. And you can see the circle with a radius of 4. So, the equation for a circle is x squared plus y squared is equal to the radius squared. So if we just try to solve to get one of the variables, we plug in what we have, which is our radius. So we have x squared plus y squared is equal to 16, because that is 4 squared. And we have y squared is equal to 16 minus x squared. And then you take the square root to get y by itself. And so we'll have the square root of 16 minus x squared. Okay, one thing to note is the rectangle is going to be going inside of the circle. And so here's going to be the y and the x-axis. So technically, if you look at it, like here's a x and there's a y, we're actually going to have 4 rectangles inside of there, and that will give us the total area of our particular rectangle that we're looking for, because we'll just section it off. And so we see that this is going to be going in right there. So we'll just change our equation up just a bit. Area sub t for the total area is going to be equal to 4, because we have 4 rectangles x, y. Okay, so now since we have just found our y, we'll substitute that in right there, and we should have the total area is equal to 4x times the square root of 16 minus x squared. So now that we have everything in the equation set to one variable, it'll make it a whole lot easier to solve and be able to take the derivative of. So our next step will be taking the derivative of this equation right here. Okay, so here's our equation, and I have just rewrote it right over here to the right. And as you can see, the only thing that has changed is, instead of the square root of 16 minus x squared, we now have 16 times x squared raised to the 1/2, because when you take the square root of something, it's basically just raised to the 1/2 power, and that'll make it a whole lot easier to work with when we start to take the derivative. So we go ahead and take the derivative. At prime is equal to 4x times 16 minus x squared to the 1/2. And as you can see, we can use the product rule on that. So whenever we take the product rule, that is going to be the first times the derivative of the second plus the second times the derivative of the first. So that's our product rule. So our first part is 4x. So we'll just say 4x times the derivative of the second. We use the power rule to take the derivative, so we get 1/2 comes down. 16 minus x squared. Now we have to subtract 1 from the power, so 1/2 minus 1 gives us a negative 1/2 times the derivative of what's inside, and so that is negative 2x. And that's going to be plus the second, which was 16 minus x squared to the 1/2 times the derivative of the first, which is just 4. So now whenever we clean that up a little bit, we get 4x over 2 from these two right here. And that's going to be times 16 minus x squared to the negative 1/2 times our negative 2x. And that is going to be plus, we're going to have 4 times 16 minus x squared to the 1/2. And our 2 will go into 4 2 times. So up top we're left with 2x times. I'm going to go ahead and pull our negative 2x right over here to just rearrange it to make sure we don't lose it. And it's going to be times 16 minus x squared to the negative 1/2 plus our 4x times 16 minus x squared to the 1/2. And so that's going to give us negative 4x squared over the square root of 16 minus x squared. And that is because right here we have a negative sign, so that means we're going to put it in the denominator, and then we're going to have the 16x squared down here in the denominator, and since we still have just a 1/2 power, that's the square root. So there we're going to get negative 4x squared over the square root of 16 minus x squared. Then we still have our plus 4 times the square root of 16 minus x squared. And that is still our total area prime. So here's the equation that we had. Our total area prime is equal to negative 4x squared over the square root of 16 minus x squared plus 4 times the square root of 16 minus x squared. Well, this is actually over 1, so in order to add those we need to find a common denominator, and so we can just multiply that by 16 over x squared, or 16 minus x squared, I'm sorry. Because this right here is just equal to 1, so we're not technically going to be changing our value. So that gives us negative 4x squared plus, whenever we multiply across on the top, we have 2 square roots, so that's just going to give us what's inside. So we're going to have 4 times 16 minus x squared, and all of that is going to be over the square root of 16 minus x squared. So we can clean that up a little bit. Negative 4 x squared plus 4 times 16 is going to be 64 minus 4x squared over the square root of 16 minus x squared, and that will clean up to negative 8 x squared plus 64 over square root of 16 minus x squared. So here's our total area prime being equal to negative 8x squared plus 64 over the square root of 16 minus x squared. So now just set that equal to 0, and so long as the top is 0, that's going to give us our 0. So really just got to worry about the top. Plus 64. So we're going to have negative 64 is equal to negative 8 x squared. Divide both sides by negative 8. And we're left with 8 equals x squared. Take the square root of 8. And that's our x. Okay, so now that we have our x, we can take and plug that into our equation that we had for y. And if you remember way back, we had y being equal to the square root of 16 minus x squared. So now we just substitute in the x that we found for our x there, and we have y is equal to the square root of 16 minus the square root of 8 squared. So whenever you square a square root, you're just going to get that number. So we have y is equal to the square root of 16 minus 8. And of course, whenever you do that, you get y equals the square root of 8. So those are our two answers. If you wanted to reduce it down a little bit more, you could. We're not required to in class, but that is the same as the square root of 2 times 4. And you'll note that the 4 is a perfect square. So if we take the square root of 4, we get 2. So we can pull a 2 out. And that is going to be still multiplied by the square root of 2. And since 2 is not a perfect square, we can leave that in the radicand. And so that should be our answer right there, because if you think about it, for a circle, what will give you the largest area inside of that circle is a square. And sorry, my circle isn't perfect, but anyway, the longest distance like that is the diameter, which is 2 times the radius, and all of that good stuff. But if you remember a little bit of geometry, technically a square is a rectangle. It's a special kind of rectangle, So for our x being equal to 2 square root of 2, and our y being equal to 2 square root of 2, our sides are equal, and that gives us our square. And congratulations, you just found a rectangle with the largest area that can be inscribed inside of a circle.